Hi, Ms. Smith again with Enrichology Tutoring, bringing you another video on rational equations, solving a little bit more difficult ones. So here I have an example problem. I have x cubed plus 1 over x squared plus 2x. So here, the first thing I'm going to do is go to my little acronym up here, hide z. I just had to come up with something. You can create your own little mnemonic device, but it helps me remember what I need to solve for. So the first thing I'm going to solve for is my horizontal asymptote. I'm going to take this and I'm going to break it down on my rules. I look at the leading term, the exponent on that leading term in my numerator is 3, and the exponent on my leading term in the denominator is 2. So the numerator is greater than the denominator. That will apply to this rule right here. N is greater than B, which means that I have no horizontal asymptote, but I have what's called an oblique asymptote. All right, so let's solve for that. For an oblique asymptote, I'm going to take my, I already got the answer right there. All right, I'm going to take my two problems, my two equations, and just I'm going to solve it on here too so you can see it. Beep, beep, beep. All right, I'm going to take my two equations and I'm going to divide them. I have x squared plus 2x, or x cubed, what originally was x cubed plus 1 divided by x squared plus 2x. So I place that over here. I have x cubed plus 1, but I had to put in some fillers for my x squared and my x term. So I have x cubed plus 0x squared plus 0x plus 1. Now, when we divide that, this is to help me make sure everything stays straight and I have my placeholders, everything is where it needs to be. But we're going to systematically find a 0 by doing a long division. So here, well, we're not going to find a 0. We're just going to solve for our oblique asymptote. So I have x here. I'm going to go ahead and multiply that by x squared. I end up with x cubed plus 2x. And now I'm going to subtract these two terms. That cancels out. And I'm left with negative 2x plus 0x plus 1. Now to get rid of this negative 2, the only way I can get rid of this negative 2, if I multiply it by, or negative 2x squared, is by multiplying this by a negative 2. And I'll show you why in a moment. So I'm going to multiply that by negative 2, and I end up with negative 2x squared minus 4x. Minus 4x. Let me erase that. So it'd be negative x squared minus 4x. Now, just like right here, I'm going to subtract these two equations. And when I subtract them, put my little subtraction sign right there, that effectively makes that a positive now because I'm subtracting a negative number. Now this cancels out and that'll be 0. And this right here will be negative 4x plus 1. Now, I can't do any more with this. Okay, so that's actually what will be our remainder. And I'm going to go ahead and leave that alone. But the equation for our oblique asymptote is x minus 2. So I'm going to put that right there, x minus 2. All right. Now, looking for what are called our discontinuities. So hide z, there are 3 things. We have to look for holes, removable discontinuities, vertical asymptotes, and jump discontinuities. I don't have the first or the last one. There are no holes or jump discontinuities, but there is a vertical asymptote. How do I determine that? I take my equation in my denominator. Now down here, when I factor this out, I have x times x plus 2. I'm going to set this, or both of these terms, equal to 0. Now, of course, x equals 0. That means that I have a vertical asymptote at x equals 0. Then this x plus 2, I set that equal to 0, and I solve for x, and I have x equals negative 2. These two values are both vertical asymptotes for our graph, and they tell us a lot of information about how our graph will behave or where our graph will be placed. All right, in the next video, I'll show you how to do the zeros, and we will graph the equation.